We're going to start with our next unit of notes. This is the first unit we're getting into that's really going to deal with earth science. We are now in our red book, the letter E, the dynamic earth. It's got a volcano on the front. So we are officially done with your yellow books. If you would like to dispose of those, you can do so. All right, so let's get started here with the 5 spheres of Earth. Earth's system is all of the matter, energy, and processes within Earth's boundaries. Now, there's many systems within Earth's system as a whole. For example, the water cycle, the rock cycle, the carbon cycle, the nitrogen cycle. Those are all systems that work within Earth's system. But Earth's system is the overall system that holds all of those systems together. We divide Earth into 5 major spheres: the geosphere, the biosphere, the atmosphere, the cryosphere, and the hydrosphere. So I'm going to tell you briefly a little bit of information about each sphere. Geosphere is made up of 3 layers, and the density will increase as you work your way into Earth's core. And the 3 main layers of the Earth that are divvied up based on chemical composition are the core, mantle, and crust. Now, in a later unit, we will talk about the fact that there are physical layers and chemical layers of Earth, depending on how you break them up. The biosphere is very easy to understand. It's all the living things. Don't forget about even the small living things such as bacteria and algae. If it's living, it's considered part of the biosphere. Atmosphere is made up of invisible gases that surround Earth. It's composed of 78% nitrogen, 21% oxygen, and 1% argon, carbon dioxide, and water vapor. Hydrosphere is going to be all of your liquid water. Believe it or not, 97% of our water here is salt water, which is pretty crazy. We have a very small supply of fresh water, so we have to really make sure that we're mindful of that. And 71% of Earth is covered in water, and majority of that water is salt water. The cryosphere is just frozen water, not in a liquid form, not in a gaseous state, but in a frozen state. These are often known as glaciers, which are big chunks of ice. Amount of ice is going to affect our seasons and our climate changes. With more ice, we're looking at a colder climate. With less ice, we're looking at a warmer climate. So ice definitely impacts how our climate is here and how our seasons change. All right, physical weathering. There are 2 types of weathering, physical and chemical. Physical weathering is the process by which rock is broken down into smaller pieces by physical changes. All you need to understand about weathering is that it's breaking down something. So think about having a rock in your hand and hitting it against a different rock and it breaking into pieces. That right there is weathering. The breaking down of materials is weathering. Now, rock breaking down other rock, like my example just included, is actually called abrasion, which is a type of physical weathering. There are many causes of physical weathering. Those things include temperature change, pressure change, animal action, plant action, wind, water, and gravity. So all of those things impact how quickly something can physically weather. Like I said, abrasion is the breaking down and weathering away of rock material by the mechanical action of other rock. It's important for you to understand that abrasion is basically rock hitting rock and breaking it down. It is a type of physical weathering. Chemical weathering is the breakdown of rocks by chemical reactions. The agents of chemical weathering is oxygen or air and acid. A great example would be rust. When you leave your bike out and it gets rusty, it's been exposed to air and oxygen, and that can cause rusting, which is a form of chemical weathering. Erosion. Erosion is basically moving things from one place to another. So weathering breaks something down, erosion moves it from one place to the next. So erosion is the process by which sediment and other materials are moved from one place to another. Now, erosion can be caused by wind, water, gravity, and ice. Similarly to erosion is deposition. Now, deposition is the dropping of material. So weathering breaks it down, erosion moves it from one place to the next, and deposition is going to drop it. And again, the same agents of deposition are the same as erosion. If you notice, wind, water, gravity, ice, wind, water, gravity, ice. They both have those same 4 things that can cause erosion and deposition. Okay? How does ice shape Earth? We know that ice can cause erosion and deposition. So how does it shape Earth? Mostly through glaciers. Glaciers are large chunks of ice. Glacial drift is materials that are picked up and carried and deposited by a glacier. What you should think about is, let's say we have a large piece of ice and we let it melt. And when it melts, some of the sand and materials beneath it are now submerged in water. Well, let's say it gets really cold again. What happens to water when it's really cold? It freezes and it's creating ice again. Now those pieces of sand that the ice cube melted are able to pick up the sand because it got frozen into the glacier, and the glacier then may move down naturally because of gravity. Well, when it moves down across Earth, it scrapes and scrapes and scrapes, and as it scrapes, some of that material from the glacier may break off. When it breaks off, it's moving that stuff from one place to another, which is erosion. When it drops off that material somewhere else, that's called deposition, because deposition is the dropping. Okay? Water shapes Earth in many ways. Water can mainly, a really big part of this is rivers. Rivers move because of currents. Currents are impacted by the gradient, which is the slope or elevation of the river. So how steep is the river? Load is the materials that are in a river, and discharge is the amount of water that a river can carry. So those three things, gradient, load, and discharge, impact a river's ability to erode things. If it's got a higher gradient, it's going to be the current's going to be stronger and faster. If it's got more materials can hit off different rocks and cause weathering and erosion and deposition. Discharge is the amount of water that a stream carries. More water can carry more things, which can lead to more erosion and deposition. Now, water erosion creates many, many, many landforms, and I did list all the landforms that you have in your book just to kind of get your mind going as to what erosion really creates. It's everything that we know around us. Canyons, valleys, deltas, floodplains, sea caves, sea arches, sea cliffs, beaches, caves, and shorelines are all created through water erosion. Now, caves are specifically formed through groundwater. Groundwater is exactly how it sounds. It's water that's trapped underneath the ground. That water trapped underneath the ground has the ability to wear down the rocks down there and erode it and deposit it to create sometimes a little hole, which can become a cave eventually over a lot of time. It's important to note that the process of weathering, erosion, and deposition are not fast processes. They take time, and they gradually happen over a long period of time. Now, shorelines we know are basically where the water and the land meet. And those shorelines all have different shapes. And their shapes are going to be impacted by how strong the current is and the waves of whatever body of water it's going to meet up with. So that's just something to keep in mind, that shorelines are also impacted by waves and currents, which is going to create that landform of a shoreline of what we see. Or like a beach. When you look at the beach, how much beach or how little beach you're showing is going to impact by how much water there is. When we have a lot of rainfall, our water levels rise, you're going to see less beach because more of that beach is going to be covered. If we have a drought, we don't have as much rain, more of the beach is going to be exposed because less water is over top of the beach. Gravity can also shape Earth through deposition and erosion. There are two types of mass movements: slow mass movements, exactly as they sound, they happen slow, and rapid mass movements, which happen very fast. Now, gravity we know pulls something down naturally. So the extremely slow movement of material downhill is called creep. Great example of this is a tree. A tree can grow with its roots gradually downhill, and that's a very, very slow process. Think about how many years it takes a tree to grow, and it can slowly move that tree and erode it and weather it. Rapid mass movements happen very quickly. Rock falls, mud flow, landslides, all of those would be very fast rapid mass movements. Wind can also shape Earth. Wind can, through abrasion, as we previously mentioned in physical weathering, abrasion is when rock hits rock and breaks it down. So wind is going to blow sand and other particles against surfaces and slowly break it down. That's also known as abrasion. Now, deflation is the removal of fine sediment by the wind. So the top layer is going to be very fine sediment of soil or sand, and the wind is going to remove that top layer because it's going to pick it up and blow it to a different location. It's picking it up and bringing it somewhere else is called erosion. It dropping it to someplace new is called deposition. It's going to leave the rock fragments that are too heavy to be moved by the wind. Those rock fragments will stay there because they can't be picked up by the wind, and that's known as desert pavement. So wind can shape Earth by abrading rock and breaking it down, and by creating desert pavement, scooping up all those fine sediment particles in the soil and leaving just the large particles that cannot be picked up by the wind. Dunes can also form. Dunes are literally just mounds of sand. They move the same direction as the wind, so you can very easily tell which way the wind is moving based on looking at a dune. They accumulate very quickly, and the sediment goes only a short distance. Now, a loess is very similar to a dune. A loess is a thick deposit of wind fine-grained sediment, which is just a pile of sand, but a loess is going to accumulate a lot slower. The wind's going to carry that sediment for longer distances, and it will pile it up. It creates a loess. Forms really good soil for crops, so loess can be very good for the fertility of crops, and it can take a lot longer for it to form because it's going to make that sediment travel further. Whereas a dune's going to be quick and short distance, loess is going to be longer distance and a lot slower to create. All right, our last lesson of this unit is soil. Soil is a loose mixture of small rock fragments, organic matter, water, and air that support the growth of vegetation. Soil is formed by weathering and erosion, which is why it's in this unit. Kind of seems to stick out as in, like, why are we talking about soil in this unit? But soil is what gets weathered down, eroded, and changed. There are 5 main properties of of soil, and I apologize, I forgot to put the fertility down below. It is color, texture, chemistry, pore space, and fertility. So fertility would be that 5th one. I just forgot to enter down. Sorry about that. And soil. Layers of soil. There are 3 main layers of soil: Horizon A, Horizon B, and Horizon C. As you work your way into the soil, you're going to get a lesser amount of humus, which is decayed organic matter, and it's going to be less developed. So your bottom layer is going to be your least developed layer. It's going to also be the layer that has the least amount of humus. That is Horizon C. Horizon B is going to be not as developed and have a little less humus than Horizon A. And Horizon A is the topsoil. It's going to have the most humus, and it's going to be the most developed layer. Now, Horizon C will also have the largest rock fragments because those fragments aren't exposed to elements such as wind, water, ice, and gravity that break those rock fragments down and weather it. So those rock fragments are going to be actually larger. Now, I know it looks like hummus, and I do have a habit of saying hummus sometimes because that's something we commonly eat, but it is pronounced as humus, and it's decayed organic matter. So just basically broken down living organisms that have gone into the soil. So decayed organisms could be a plant, could be an animal, could be anything, could be bacteria, algae, any of that breaking down can be considered humus. All right, and that is the end of the notes. So thanks for watching. Don't forget to hit update on your blogs. See you next time.